So VPT explain the geometry of the complex, and this geometry is explained on the basis of hybridization. If the central metal atom have sp3 hybridization, it has a tetrahedral geometry. And if the central metal atom have sp3d2, this its structure is octahedral and is the outer orbital complex. And if the hybridization is d2sp3, then it is the octahedral but inner orbital complex. And if the hybridization is sp2d, then the geometry is square planar. So on the basis of hybridization, the VPT explain or predict the structure of the molecule or the complex. Hello dear learner, welcome back to the Zoom Chemistry Hub. Today with another interesting and informative video in which we will discuss the most important and valuable topic, that is valence bond theory, VPT. So first we will define valence bond theory. Valence bond theory explains the bonding in coordination compound based on the overlap of atomic orbital and the formation of hybrid orbital. It assumes that ligands donate electron pair to the central metal atom, which accommodate them in its hybridized orbital. Now we will discuss the main points of VPT valence bond theory. First point, metal ligand bond formation. In the bonding occur due to the overlap of filled ligand orbital with empty metal orbital. That is, the bonding is occur between the ligands and the metal atom, and metal atom have empty orbital and ligand have a pair of electron in their orbital. Second point, hybridization. The central metal ion undergo hybridization to form a specific geometry. So in the coordination compound, the central metal atom undergo the hybridization to form a specific geometry. Next point, point number 3, nature of complex. VPT explains the formation of inner and outer orbital complex, that is n-1d, that is the inner orbital complex, and n-d orbital, that is the outer orbital complex. Next point, magnetic properties. VPT explain to determine the whether the complex is paramagnetic or diamagnetic based on the electron pairing. So the based on the electron pairing, VPT explain that the coordination compound is paramagnetic or the diamagnetic. Point number 5, VPT explain the geometry of a molecule, that is the geometry predictions. It predicts the shape of complex based on the hybridization. So VPT explains the geometry of the complex, and this geometry is explained on the basis of hybridization. If the central metal atom have sp3 hybridization, it has a tetrahedral geometry. And if the central metal atom have sp3d2, its structure is octahedral and is the outer orbital complex. And if the hybridization is d2sp3, then it is the octahedral but inner orbital complex. And if the hybridization is sp2d, then the geometry is square planar. So on the basis of hybridization, the VPT explain or predict the structure of the molecule or the complex. Next point, examples of in coordination compound. That is, we have an example of hexamine cobalt 3. Here cobalt plus 3 have the electronic configuration 3d6 and its hybridization is d2sp3. So the inner orbital complex is formed d2sp3. And its magnetic property, it is a diamagnetic in nature, as all the electrons in the inner orbital are paired, and its geometry is octahedral. Now the applications of VBT. First, VBT explain the bonding in coordination compound by hybridization. Next application, VBT explain or help to predict the molecular shape. Point 3, VBT determine the magnetic properties of the complex, either it is paramagnetic or diamagnetic. Point number 4, VBT used in understanding bioinorganic chemistry, that is the hemoglobin molecule. Point 5, VBT applied in catalysis and industrial applications. Next, what are the reasons by which we using the VBT, valence bond theory? VBT is used due to its simplest and intuitive, that is, it is easy to understand and apply. Explain basic bonding. It provides a fundamental understanding of metal ligands interaction. Metal and ligand interactions is explained by VBT. Prediction the geometry, or VBT predict the geometry of the molecule. So it helped to determine the molecular shape by using hybridizations. Next, we will discuss the limitations of valence bond theory, VBT. First, it fails to explain the color, so it cannot predict the color of the coordination compound. Its first failure is that it cannot explain the color of the coordination compound, which is explained by the crystal field theory or crystal field splitting. Next, does not explain the spectral properties, that is, VBT cannot describe the electronic transition, that is, in the crystal field splitting the DD transitions occur, but here VBT did not explain the electronic transitions in the DD orbital. Next limitation is magnetic behavior, sometimes incorrect. It predicts the wrong magnetism in some cases, that is, in the case of O2 molecule. Next, no quantitative aspects, so it cannot calculate the bond strength or bond stability. Next, ignore the ligand field effect. It does not consider the influence of ligand field splitting like the crystal field theory, which is explained in the crystal field theory of the ligand field effect, but here VPT did not explain the ligand field effect. Conclusion: Valence bond theory is a useful but limited approach to understanding the coordination chemistry. While it explains bonding and geometry well, but it lacks accuracy in predicting the color, magnetism, and electronic spectra, which is explained by MOT or crystal field splitting, crystal field theory. More advanced theory, that is the crystal field theory CFT, and MOT, that is molecular orbital theory, for deeper understanding. That's for all today, the learner. If you have any query related, please do write me in my comment box, and if you like this video, please like, subscribe and share with your friends and fellows so we can grow each other. Thanks for watching.